G3 केवल T2 इसमें ना एक इथल एसिटेट ब्लैंक पड़ेगा इथल एसिटेट सॉल्वेंट ब्लैंक तो चलता रहेगा. Tomorrow we can verify the data. Now I'll develop the method and I'll start injecting. I'll show you how it injects. Yeah? This is your roadmap. You can see here instrument setup, instrument method.
Please.
हाँ.
आपको दिख रहा है सर?
ठीक है, तुम पीछे आ जाओ. See here.
मैं पीछे आ जाऊँ.
Instrument setup. Yeah.
I'm saying today it is hanging. Earlier today in the morning also it was slow.
It happens.
Try it. Try to reach.
Internet connected.
Yes.
Okay. So this is your devices which are configured. One is your GC with auto sampler and another MS. First we'll go with the GC parameters. I'll go one by one. Next, so it's a triplex RSH is our sampler. Inject valve, direct injection. I'll go with this. See here, we have this auto sampler. Within this auto sampler, we have multiple types of sample injection types. See here, GC liquid, GC headspace, SPME, SPME arrow, ITEX. So now we are working with the GC liquids. So before going to develop the method, you must ensure what is the injection module we have on the system. That also I will show you. Before injecting, I will show injection module. Let me just try. Okay, anyway, tomorrow we are changing. I'll show you that time. SPME we are going to change it now. Now it is a injector 1. So first injector 1. So here we don't have injector 2. Back side we don't have. Everything is by default. This is 10 microliter syringe capacity. The height will be 57 mm. Wash station, standard wash station. So these are all the hardwares are selected. Now I'll go for a create new method. First we have to define the parameter of the auto sampler, auto injector, and then GC, then MS. First we'll go with the general parameters. These are all default. So sample volume, syringe volume, everything is default. Now we are going to take what is the sample volume we are going to take. Let me take 1 microliter or 2 microliter. I'll take 2 microliter now. Air volume, see here we are going to take some sample volume. Air volume we are going to take 0.5 ml or 1 microliter of air because to save the sample loss. So we are going to take the liquid of the sample. It will retain up to the tip of the needle. Sometimes it may spill out or evaporate out. To avoid that, we take some air inside. Fill stroke before taking sample, it will try to remove the air bubbles. For that reason, we are going to take fill stroke 2-3 times. Volume automatically. Sample vial depth, you can take 30 mm. It will go up to 50%, means half of the vial. Sometimes if your sample is less than 100 microliter, 200 microliter, always you have to take a bottom sense option. So then needle goes up to the bottom, it will sense the bottom, take the sample and inject. Otherwise, if sample volume is less, it is 30 mm depth.
सबने अपना नाम चेक कर लिया इसमें.
Okay. So this is the means the needle depth to which distance it has to reach in the vial. Okay. So if it is 30 mm, it will go up to 30 mm from the bottom and bottom sense. Generally, in less sample volume, you can go with the bottom sense. Next is your injection depth. That is by default, automatically it happens. Pre-injection and post-injection delay time. We have pre-injection and post-injection delay time. What does it mean? So we are giving 2 seconds. The sample needle will take the sample, goes into your inlet, position in the injection position. It will penetrate through the septum, goes to your liner. Before plunging out the sample, dispensing out the sample, so it will wait for 2 seconds. Then after injection, so post injection dwell time. After injection, immediately it will not come out. It will wait for another 2 seconds, and then later it comes out. So within that time, what happens? If there is any traces of your vapors or liquid in the syringe, it will dispense out properly. And then viscosity. So if you are injecting any sample, it is slightly viscous in nature. So the syringe, the neat solvent easily it will aspirate. If it is a viscous sample, it takes its own time to take out. So take into your syringe. So that's the reason you have to take viscous sample. Take any viscous sample, or you can say customization. Customization not required. Next, this is all about the volume of sample injection and depth of sample injection. Next is your washing, because we are using the same syringe. We have only one syringe. We are using the same syringe for multiple sample injection. So it will go contaminate again and again. For every sample, it is going to be contaminated. For that, we need to wash the syringe properly. For that, we have a washing solvent. So A, B, C, D. We have A, B, C, D, 4 different solvent set, and last it is a dispenser. A drainage block. Okay, all the waste will be dumped in that last vial. Here, what do we do? Pre-wash. See here, that is a standard wash station. See here, pre-wash, post-wash. Pre-wash, I will take in the A 3 times. Volume 3 microliter. I will go with the multiple solvents. Okay, if it is single, it will show only one. I'll go with multiple. Again B. A and B 3 times. This is with the pre-injection. Pre-injection will be always a cleaned syringe, because it will post. So once the sample is injected, after injecting the sample, the post-wash happens, and that will be cleaned. Before next, for the next sample, the pre-wash also will be happen, because it is already cleaned syringe. Again, it will be cleaned, rinsing before taking the sample. But the contamination level is very high in post-wash, because post-wash after handling the sample. Clear? Now rinse with the sample. Sample rinse also I will take 3 times. I will take 2 microliter here, or 3 microliter. Okay. Now here I will take C and D. Post-wash requires slightly higher time.
So
okay?
why C and D?
See here, A, B, we have taken. Why? Because pre-wash and post-wash, if you are using the same solvent or same vial, the contamination level is higher in post-wash. The same contamination will go for the pre-wash also. Pre-wash should be completely free from the contamination. So that is the reason we suggest always go with the different vials, either A or A, B. So whatever you are going to do, so you dedicatedly use for pre-wash and post-wash separately. Then there will not be a kind of cross-contamination. Clear?
So what are the solvents that you use?
Generally, the solvents are going to take, one will be your diluent, whatever the sample you are, sample preparation diluent you can use. Other one, polar, non-polar, mixing also you can use. So depends on what type of matrix you are using. So whether it is completely removing out or it is not properly soluble, again it is to be used.
So
But
having those solvents to washing will it not affect the machine?
no, it is all about the syringe wash.
But this syringe will have the sample and eventually it will.
See, even if you inject polar solvent or non-polar solvent, it will not harm your system. It will not retain the molecule in your stationary phase. So there is no interaction. So it will just pass through. There is no proper interaction with the stationary phase, and it will not retain the molecule. Okay? Yeah. So this is all about your auto sampler. Okay? Injections means parameters and washing parameters. So that is all about, and synchronization, these are all means predefined. So this is all about the configuration. Okay? Now I'll go with the GC part. Here GC we have column front inlet. The column connects in the front inlet. The carrier gas also be required. I am not using the FID now, so that I'll just remove the back detector. Okay. Now I'll go with the next. Here first we have to define column flow, means constant flow or column flow. So column flow you can either constantly given a flow or ramped it time to time. So suppose for 5 minutes one means the column flow will be different volume, and again after 5 minutes different. That also you can do, but I will always go with the constant flow. Okay. So 1.2 ml or 1.5 ml, whatever you can do that. That again depends on number of molecules and the separation nature. Next is your inlet parameters. Inlet parameter where you are injecting the sample and that is going to be vaporized. Okay. So generally inject parameter it will be 280, 300, depends on the molecule we are using. Now we are working on the pesticide. For pesticide 280, 300 is sufficient. Here I am using splitless, because split I am not applying since we are working in a lower concentration level. So I will go with the CT splitless. Here you have normal splitless also. If you use normal splitless, you can program it. like PTV, program temperature vaporizer. You can program everything, but I'm not going to program now. Okay, I'll keep it CT splitless. Inlet temperature is 280. Split flow I'll keep it 30. That's fine. Splitless time 1 minute. Punch flow control 3 or 5. And this is all minimum requirement. Then vacuum compensation. Vacuum compensation is compulsory in case of MS because MS is working under vacuum. So that compensation should be always there whenever the sample reaching to your detector or there is any carrier flow, everything. Have a gas saver module. So that you can see. Gas saver module, you can define the parameter. Now we don't have gas saver. Okay. So here you can define, so vapor volume calculator, what is your liner which is fixed inside and what is the solvent you are injecting. Based on the liner, your vapor volume capacity can be decided. Now say for example, if I am using a SSL 4mm ID, split or splitless and split, you can see the difference, 0.986, 0.860. Okay. If I take this, I am using methanol as a solvent. I am injecting 1 microliter. So the capacity of the liner is 0.986, approximately 1 ml capacity. 1 ml vapor it can accommodate. But when I am injecting 1 microliter of methanol, it gives 0.48 ml of vapors. So maximum I can inject, I don't think 2 microliter also can be injected. Yeah, 2 microliter I can inject, 3 microliter cannot be injected. It is exceeding the volume. But in case of I am using hexane, go with hexane. Here if I am using 1 microliter, it is just showing 1.49, means 1.15 ml, 150 microliter. I can use 5 microliter also, it will not exceed. 6 microliter also it will not exceed. Means the density or linear velocity, whatever the means vapor velocity, everything is vary from solvent to solvent. So whenever you are using different solvent, you can accordingly manage the volume of injection. Okay. This is just a utility calculation to develop the method. Closing it. Now I'll go with the next runtime, preparation runtime. This is the standby time of a GC. Then I'll go for the method ramp. Initially I'll set up the method 60 degrees Celsius for 1 minute, or I can say, so because we don't have much knowledge, I'll go with 20 degree. Since we have spiked only one standard, there are 2 standards, 20 degree up to 280 degree. What is the run time now? I'll make it 4 minutes. Just check. 15 minutes 4 I can. So this is a simple program I have just given, because this need to be programmed whenever you have more number of analytes. How it is going to be defined? Generally what happens, we have a number of mixtures. Say for example, I'll explain here only. So say for example now, we have a mixture of 100 compounds. Out of 100 compounds, so the compounds elute out within means 150 degrees Celsius. Probably we are boiling point from 80 to 120. Imagine 30 compounds. And 120 to 150, there are 25 compounds. 150 to 200, there are limited 10 components. So accordingly, the temperature zone and timing, wherever you have more number of compounds in a short temperature increment, you have to reduce the incremental rate, so that it will be having a sufficient enough time to separate the molecules. Okay. Then wherever you have limited number of compound and more temperature range, you can slightly increase the ramping movement of the molecule. So this is a slightly skilled job, depends on the molecular separation. You can set up the program. Now I'm just going with the simple, because I have only 1 or 2 standard. We have to define the column configuration. What is the column we are using? What is the length, dimension, everything. Accordingly, the gas flow pressure will be set. No, not default. It's based on column configuration. Your gas flow pressure will be set. Now, this is all about your GC parameter, mainly your inlet parameter, O1 programming, and your carrier flow, column specification. Next is your detector. I've just created this. I'll just check the method once. Bug detector, we have one more detector in the FID, in the GC. So that we have not connected the column to that. So that is a different detector. So both the detector will not work together now. You can configure it, so you have to connect both the columns to the both detectors. Okay? By default, when you open, it shows. Okay? So tomorrow we are using FID for fatty acid interactions. I will show you. It's clear? Now I'm just checking the method. It is all parameters are successful. There is nothing called error mismatch. If any mismatch, it will show here. Next is you can see the parameter one by one here. What are the parameter? If you want to modify anything, FID. This is the FID parameter. I'm not using this. Okay. Now I'll go to MS parameter. Here in MS we have two types of acquisition. First we go with the general mode of acquisition. So where we have to inject it is 280, right? Transparent temperature ultimate 290 and ion source 300, 310, 320. Okay. So ionization method is EI. GC runtime. Throughout GC runtime it will scan, but initially I avoid the solvent delay time for 5 minutes because I know till 5 minutes I don't get my molecule. Now the mass range we have to define 40 to 450. Now we have spiked. What is that? SF8 one, no? SF8. See all your masses above 40 to 450. Another one is chlorpyrifos. So start from 40. I'll take all this 450. All the masses are covered. I'll go with this. Now, so next we will see later. Now it is all about your dwell time means data acquisition time. Dwell time means the one data point collection rate. Every 0.2 seconds it will collect one data point. Okay. So this is the very simple method for the identification. For quantification you have to define. You have to go to timed mode. You need to select SIM or SRM. Then define the component name, component RT, masses. So then only it will scan specifically. Now we are doing qualitative. I'm just going with the general acquisition. Clear? Any doubts? Okay, I'll save this method. Okay, try me. I'll create. Okay, I'll save this instrument method. Okay, now instrument method is created now. We have to submit to instrument for the injection. Here, this is the window. Here I would say this is the roadmap where first we have created the instrument method, then we go for a sequence setup. Once we submit the sequence, then we read the data in the qual browser using library browser. Okay. Now I'll create sequence. I'll create the new sequence. Here I will take one blank. Diluent. Path I will select here. See here. Xcaliber training workshop data. So all our raw chromatogram will be saved in the C drive Xcaliber folder workshop data. Instrument method, now I copy the instrument method, Xcaliber training workshop instrument method. This is the instrument method. So instrument will acquire the data under all these conditions, whatever we have defined. Processing we will do later. Okay, and rest of the thing we will do later. I will just save this. Workshop sequence. Okay, now I'll just demonstrate only one. Later I will inject all the standards. Okay, because another batch also is there. We have to do that. Now I'll just select this for injection. So you have to ensure instruments are ready to inject, means ready to download. Okay, if they are not ready, we cannot inject. Now it is controlled, all parameters standby. This is also okay, and MS is also fine. I'll go with this. I'll select it. I'll acquire run sample or run batch. If you have multiple samples, you can go with the run sequence. Otherwise, run sample. It will ask while running what should be the instrument should start first. See, thermo Xcaliber, right? So GC is going to start first, and I'm injecting the row, only one we have here. If you have any standby method or shutdown method, you can select it and submit. After sequence completed, automatically it will go to standby or shutdown method. Okay, so here processing, we are not assigned any processing method. If you have, you can select the quantitative or qualitative processing. Okay, now I'll just go with simply submit. Once it is submit, it has gone to the acquisition queue. Your system status is going to change. Preparing for run. Once all the parameters are ready, now what parameters? Oven temperature. What is the oven temperature we have given? 60. Now it is going for 60. Then other things, front inlet temperature is okay. So same flow. Back inletter is not active. I come here. So this is the temperature we have defined, 290 and 310. So it takes some time to reduce temperature. After that, it starts injecting. Okay, what is the position? Position 1 now. Okay, so liquid injection we will complete today. Tomorrow we go with the headspace and your fatty acid methyl acid. Now it is pre-wash. Three times vial A, 3 times vial B. No, ethyl acetate. No, different solvents. I think one is in ethyl acetate, one is in methanol something. You can take mixture of solvents also, no problem. Now after washing, it goes to the sample. it will rinse with the sample also. Three times. Different 3 times. Now it will plunge out 3 times. So take 1 microliter and inject.